Hi everyone. So for those of you who don't know me, my name is Miss Ho, or you can call me Teacher Zyen. A little bit of introduction about myself. I am a high school teacher specializing in physics, and I've been teaching physics for more than 15 years. This is the third video I'm making in this series to help candidates who are taking SPM 2020. Now, as all of us already know, SPM has been postponed to February 2021, which is next month. It's really right around the corner. So the purpose of making these videos is to help students, to do their own online revision and to help their home studying in order to prepare better for the upcoming examinations. So a little bit of a shameless plug. This is, of course, to promote my website, physicsrocks.com. And on this page, you will be able to find free resources to help you with your coming examinations. For the time being, I am focusing on SPM 2020, but rest assured, I will be sharing more resources for students who are taking SPM 2021 and later, as well as IGCSE O levels, and hopefully I'll be putting in more physics syllabi, in other programs on this website, focusing on physics mainly. So this is the advertisement. Yeah, let's not look at that. Okay, so let's look at the free notes for SPM 2020. I do have chapter notes here and paper 3 notes. So what's in paper 3 notes? I'm just going to click so that we can take a look. And I have available here to download for free a basic guide. I recommend that you go right now. You can pause this video, go right now, take a look at physicsrocks.com and download this paper, because I'll be using this for the video and it will be really helpful for all of you students who maybe by now still not quite sure about how to answer section B, or but you just want the reassurance that you've got it right. So it's free to download and free for you to keep. So just right click and save. So what's in this paper? Now, I know it says 2018. Don't worry about that. It's actually exactly the same. The format hasn't changed since, since 2006. I just put 2018 because this was the last time which I've edited this file. But no changes have been made since then because they were not necessary. All right. Okay. So when it comes to physics paper 3, section B, let me just flip this here. Okay, I know I'm just flipping tabs for the time being. I hope you'll be able to follow the video. So here, using SPM 2019 actual past year paper as a reference, of course, a reminder, the tips and methods shared in my videos can be used for any physics paper 3 SPM based on this format, because all of them have they pretty much follow the same format, right? So I'm going to just point out here, for those of you who don't remember, okay, in physics paper 3, there are 2 sections, A and B. Each section has 2 questions. Section A has 2 questions, both are compulsory to answer. I have already covered, in general, how to answer questions 1 and 2. If you haven't seen these videos, do check out my YouTube channel. I've already uploaded 2 videos on answering questions 1 and 2 respectively. This video, we're going to focus on section B, where we're going to focus on how to answer question 3 and question 4. In this case, it's either one, not both. So whether you're answering question 3 or 4, the format is exactly the same, right? Okay, so you can see that here, question 3 and question 4 each are worth 12 marks. Like I said, you only pick one, right? So that's why they're worth the same marks. And you'll find that the questions are, the format is kind of the same. Of course, the question itself, question 3 and question 4 themselves are obviously different, but the format is the same. So if you look at question 3, here you've got 2 diagrams. They're showing you, a situation where it's slightly different. You've got a man cutting down a tree with an axe, and then a man cutting down a tree with a heavier axe. Now, if you look at the sub-questions, you got A, inference, worth 1 mark. B, the hypothesis, worth 1 mark. And then C, they ask you to describe an experiment to investigate a hypothesis. And they have further breakdowns of 1, 2, 3, 4, 5, 6, and 7, total worth 10 marks. We've got aim, variables, list of apparatus and materials, arrangement, procedure, tabulate, and analyze. Now, if you take a look at question 4, it's also the same in terms of the format. So question 4, of course, they have to change the question, obviously. Otherwise, why bother having 2 separate questions, right? So question 4, you've also got 2 diagrams. In this particular paper, question 4 shows us a garden lamp that's lit brightly when connected to a solar panel, and an identical garden lamp that lit dimly when connected to an identical solar panel. And you've got to look at the two diagrams and see, oh, okay, what's different about these two diagrams? Let's take a look at the sub-question. So you've got A, inference again, 1 mark. Hypothesis also worth 1 mark. C is also where you need to describe an experiment to investigate a hypothesis. And again, breakdowns of Roman numerals 1, 2, 3, 4, 5, 6, and 7 also worth 10 marks. Same thing. Aim, variables, apparatus and materials, arrangement, procedure, tabulate, and analysis. So whether you're answering question 3 or 4, they are, you can see pretty much it's almost identical in terms of the format. What changes, of course, is the content of the answer that you've got to present, depending on whether you're answering question 3 or 4. So what I have covered in my guide, let's go back to the guide. So what I've covered here in my guide is how to answer the ABCs 1, 2, 3, 4, 5, 6, 7. So you can see here I've got A, inference, B, hypothesis, C, 1, aim, C, 2, variables, C, 3, apparatus and materials, 4, arrangement of apparatus, 5, procedure, 6, tabulation, and 7, data analysis, and that's it. That's worth 12 marks. Now, if you download this guide and you follow the recommendations made in this guide, provided of course that your answers are correct, you should be able to get your marks. What's important here is not so much about what experiment you know, but how you present the answers. Because by now you should be aware that, yeah, it doesn't matter what kind of a physics concepts you have in your head, how much knowledge you have in here, whether you're able to come up with brand new ideas and create new stuff. Physics SPM does not test you on any of that. Okay, Physics SPM, of course, does test you on your physics concepts, but for this paper 3, more importantly, they test you on whether you're able to answer based on the format. You need to understand that this is a technical paper. When we say technical, it means the format is extremely important. You can kind of think of this as, because this is not an artsy thing, or where you can come up with brand new ideas and, bada bing, bada boom, and ta-da, whatever I want to say, that's going to get my marks. For the sciences, you do need to follow a particular format. And the reason for this format is because the format is a universal language, if you like, because science is very technical, which means that when you prepare your report a certain way, anyone who reads your report will be able to immediately understand what you are trying to say, rather than trying to figure out, okay, this is an abstract piece of work, I'll interpret it my own way. That's not what science is. Science is quite objective, which means that usually there should only be one correct answer. And that's why you have to follow this format very, very closely. So what I'm going to do now is I'm going to go through this guide, and as an example, so that we can see how to present the answers, we're going to use the SPM 2019 past year paper in order to come up with the answers, right? So let's come back here. So the very first thing that you need to do when you want to answer this question, of course, is to read the question. So when you read a question, because in this case, you only need to answer one, right? So choose either question 3 or 4. So read the questions and see which one you understand more. So let's see. So you got question 3. Diagram 3.1 shows a man cutting down a tree using an axe, and 3.2 shows the same man cutting down a tree using a heavier axe. And that's all they give you, right? And then read a little bit more. This is pretty much all standard, but what's extra here is this. With the use of apparatus such as the slotted weight, soft plasticine, and other apparatus, describe an experiment to investigate a hypothesis which is stated in 3b, which means that the experiment that you are going to be answering in this report must include the slotted weight as well as the soft plasticine. Now, take a look at question 4. We have a situation here where this particular lamp lights brightly and this lamp lights dimly. And if you look at the two diagrams, the difference here is quite obvious. this has a longer wire compared to this. And what is the apparatus you have to use? You have to use a constant turn wire, ammeter, and other apparatus. Now, before you start jumping into answering the inference and all that, the very first thing that you need to do is to identify the two variables, the manipulated variable and the responding variable. So look at both questions and see if you can identify the manipulated and responding variables correctly. Now, let's take a look at this, and I want you to think. Now, I know some of you have already done this question. Let's assume that you haven't. Use, your brain juice again and try to figure this out. Okay, so in this case, what do you think the manipulated variable could be? If you notice the keyword here, let's make this a little bit bigger so that we can see it on screen. Okay, a little bit. So you got heavier X. So what does this tell you? It is extremely likely the manipulated variable is the weight. In this case, the weight of the X, correct? Now, what about the responding variable? So look at what is different in terms of the response of changing the weight of the X. So if you look at the tree, you can see that, hey, this creates a bigger hole, right? Looking at that, then you should be able to figure out then the responding variable is the depth of impact. So some students have thought maybe it's size of hole, which if you look at it, it seems to be quite correct. Now, I'm not saying that it's wrong, but you've got to think as well, like, is it measurable? How do you measure size? So don't worry if you don't get it right on the very first attempt. As you answer questions A, B, and especially C, you will be able to kind of figure out, okay, what the correct answer should be, and you can modify your answer accordingly. So let's now look at question 4 first before we go on to answering the inference hypothesis and so on. Now, in this question, you can see that they don't give you very much information in the words, but the diagram already tells you quite clearly that the length of wire is the manipulated variable. And what about the responding variable? Looks like the brightness of the lamp, correct? Now, one thing though, like I just mentioned, it has to be measurable. Now, think about it. Is the brightness of the lamp measurable? Well, not in your syllabus, right? So my recommendation is not to use brightness of lamp. Instead, look for something that is measurable. So for example, in this case, you could suggest maybe the current that's flowing through the lamp, because the greater the current, the brighter the lamp would be, correct? So always go with something that you can measure, because remember that everything in this question, 3 and 4 in the end, has to lead to drawing a graph. So everything here must be a physical quantity. So everything that you've written here for the variables must be physical quantities that you can measure, which will enable you to eventually draw a graph in analysis. Now, if you're trying to choose between questions 3 and 4, and let's say you're not sure which is the one that you should do. Some students have told me that, okay, sometimes, when they look at questions 3 and 4 and they look at the MV and RV, and then there's one question they're very confident, like, yeah, I'm very sure this MV and RV are correct. It's just that I'm not quite sure what the experiment could be. And then when you look at another question, you're like, I'm really not sure whether the MV and RV are correct, but I'm very confident with the experiment. I think I know what the experiment, would be like. And then they tell me, you know what, teacher, I don't really know whether I should answer question 3 or 4. Do I go with the one where I am confident of the variables, or do I go with the one where I'm more certain of the experiment? So my recommendation is always go with the one where you're very confident about the variables. Because even if you didn't get the experiment quite correct, but if you have your correct manipulated and responding variables, let's say, even if you screw up the experiment section, out of 12 marks, you're still going to get 9 marks. That's right, 9 out of 12 marks. But if you identify the MV and RV wrongly, no matter how perfect and how beautiful your experiment is, it's very possible you're going to get 0 marks. Okay? So let's go through the guide, and you'll be able to understand why even having the correct experiment may not get you the marks that you're supposed to get. So let's go back to question 3. Okay, so what I've done here is I've done a split screen where I've put 2 documents side by side. So we've got the guide on the left-hand side and the question paper on the right-hand side. So I've decided to do this because I think it's a lot easier if you could see both documents at the same time rather than have to flip back and forth between the 2 tabs. Otherwise, it'll get so confusing. It's going to be so difficult for you guys to be able to follow what I'm saying. Right. Okay. My computer crashed just now, so I've got to rewrite the MV and RV, but no worries. That's not a problem at all. Okay. So when it comes to the guide, if any of you are wondering, how accurate this guide is, let me assure you that I built this guide based on what SPM examiners have shared with us teachers. Um, I've also gotten feedback from other examiners that, this is actually quite accurate. So I'm fairly confident of its reliability. And besides, if it's not accurate, I would not dare, put it up and ask students to download it. So you can download this and use it as a guide, and rest assured that it is quite accurate and can be used for answering your SPM paper. Okay. Now, before we jump into using the guide and answering all the inference and all that, of course, we already know what the manipulated variable and responding variables are, but you got to figure out the experiment as well. So for question 3, we know that the manipulated variable is the weight. By the way, I didn't write weight of x here because when you have to write the answer and build the experiment framework for this question, it has to be doable in the lab. And we're not going to be using an x in this experiment, right? So that's why don't write weight of x. I'm just going to keep it as weight. For this question, let's figure out first what the experiment could be before we jump into answering the question, okay? So we know we've got to use slotted weight and soft plasticine. Now, what do you think the experiment could be? Since it's about weight, the slotted weights are going to be what we're going to control, right? For our manipulated variable. So the slotted weights, I'm just going to do a quick sketch here first as reference. The slotted weights are those little gold weights which you can easily add on or remove to change the overall weight of the whole slots. And what you're going to do is you're going to drop it on a slab of soft plasticine. So you're going to drop it from a particular height. You're going to change the weight, of course, and the responding variable here. Now, once this has fallen, the impact will create kind of a hole, right? So you're going to do is you're going to measure the depth of that impact. And that's the experiment for question 3. Now let's look at question 4 and figure out what the experiment here could be. So as already earlier discussed, the manipulated variable is the length of the wire, and the responding variable is the current flowing through the lamp, or in this case, the current flowing through the circuit. The experiment needs to use a constant wire and an ammeter. And this is definitely a circuit question, right? So which means the experiment definitely needs to have power supply. You need to control the length of the constant wire between the crocodile clips. You need to have an ammeter, of course, in order to measure what the value of current is flowing through the circuit. Right, and actually, if you look at it, that's pretty much it. If you want to be on the safe side and a voltmeter, by all means go ahead, although it's not necessary because you already have the responding variable measured here by the ammeter. Okay, now let's go back to question 3 and let's figure out how to use this guide to answer the question. Okay, so now that we have figured out the experiment, let's get right to the answer. By the way, it's been wiped clean because my computer crashed again. But you know what? I'm just going to continue with the video. Otherwise, we will never get to upload this video, right? So For question 3, now make sure that you write it out clearly on a piece of essay paper. Don't be scribbling the answer, in between the questions, over here, and then you submit it as is. That's not how you answer the question, all right? So you've got to write an answer on a fresh piece of essay paper. Don't have any, just ask the examiner for some, all right? But for the purposes of this video, I am going to type the answer out in a Google document. Okay. Make sure that you follow the demarcation. That means the breakdown. Write out the A, B, C, 1, 2, 3, 4, 5, 6, 7. Okay. So for question 3, starting with A, okay, as you can see, how you write the inference is MV affects RV. And it's pretty much fill in the blanks. All the grayed out spaces here, you just need to fill in the blanks as per the MV and RV that you've identified for that particular question. So for our question 3, we know that weight is the manipulated variable and depth of impact is our responding variable, and that's all you write. Next, hypothesis. How you write the hypothesis is like this. You can write the greater the MV, the greater all over the RV, of course, depending on what the relationship is. Another way, which I didn't share here, you can write when the MV increases, the RV increases or decreases. So for the Google documents, I'm going to write the second method because it's not in the guide. It's just to show you that's also accepted. So when the weight increases, the depth of impact increases. Next is C1, which is the aim of the experiment. Now, how you write the aim of the experiment, is just write to study the relationship between the MV and RV. And that's all you need to write for your own aim. So to study the relationship between the weight and the depth of impact. C2 are the variables, and you need to write all three: the manipulated, responding, and constant variable. You already know the manipulated and responding variable. So just write that out. Now, when it comes to the constant variable, you must remember that for physics, all three variables, manipulated, responding, and constant, must be physical quantities. So you can't write objects. For example, if you're going to write, the weight, the water used, for example. You can't write things like that. It has to be something that's measurable. And the constant variable must be something that could potentially change the responding variable. So if you come up with the idea, okay, this could be the constant, then you got to think, if I change this particular variable, will my responding variable change? If your answer is no, then that's not your constant variable. Typically, constant variable is another factor which can affect the responding variable, which means, like, say in theory, you want to come up with another experiment to see how this variable affects this variable, and it's not the same as what you've got in the question here, then that can be your constant variable. So for example, in this particular question, we already know, let me just draw it out again since I've lost it. We already know that we're going to be dropping the slotted weights, right? Like here's the slotted weight, here's the plasticine, we know we're going to drop it. And I want you to think, if we change the height of drop, wouldn't that change the depth of impact? It would, right? Which means that in this particular answer, the height of drop is our constant variable. Next is our apparatus and materials. For physics, you do not need to separate the list. You can combine the list into one line. And typically, you should have at least 5 major ones. If you don't know what apparatus and materials to write, normally I advise my students, do a sketch first to see what you need. And based on that sketch, what objects you have in there or what materials you have in there, then you just fill in the list of apparatus and materials. So we know for certain, of course, we have the slotted weights and soft plasticine because it's in the question. What else do we need to use? You got to think about what other measuring instruments you would need to, to measure whatever the manipulated, responding, or constant. So in terms of responding, we need to measure the depth of impact, correct? How are you going to measure the depth of impact? My recommendation is to use vernier calipers because if you remember, the vernier calipers has a stem. That stem can be used to measure depth. Now, it's not wrong to suggest using a ruler. It's just that most rulers, usually the starting point of zero does not start from the edge, which means that it makes it very difficult to measure the depth of impact, which is why in this case I suggest the vernier calipers. But it's not wrong if you want to go with ruler. Okay. Next, the height of drop. How are you going to measure the height of drop? You can use a meter rule, right? So I'm going to put that in, meter rule. Now, like I said, you typically need at least 5. But if you've like, okay, I think that's actually all I need or anything else. If no, then quite possibly this is all that you need. So let's leave it as that. Next is the arrangement of apparatus. Arrangement of apparatus is, of course, the drawing, the setup. So when you draw, please use a pencil and complete it with labels. If you just draw with no labels, you will get no marks. So for this, I'm going to use the Jamboard first to draw. Of course, for you guys, you can just draw it straight in your paper. Okay, we have the slotted weights. So make sure that you label clearly. No label, no marks, no matter how beautiful your drawings are. And this is the soft plasticine, right? It's a slab of plasticine here. Okay, and you can also add a meter rule, just to show that this is how you measure the height of drop. Okay, and I think that's pretty much it, right? You don't have to draw the vernier calipers because we haven't done the experiment in this diagram, so you don't have to show the vernier calipers, but you do need to mention that in your procedure later. So we're just going to export this so that I can import it in here. This is just for the sake of completion so that you can see how to complete the report. Just gonna put that in. Okay, there we go. Right. Next, this is the part that a lot of students do not like, which is the procedure. Now, do you recall how many lines of procedure that you need for Physics Paper 3, Section B? You need only 3, as written in the guide here. 3. First mark is given for mentioning the method to control the manipulated variable. Second mark to measure the responding variable. And third mark is for repetition. Okay. It's also stated in the question, although it only mentions the first two, method of controlling the manipulated variable and method of measuring the responding variable. If you're thinking, are you sure it's 3? I'll show you the marks breakdown shortly. So how do we control the manipulated variable? Okay, so as mentioned in the guide, you just need to state the initial value of the manipulated variable. Actually, there's 2 things. First, state that initial value. Secondly, mention what you're going to do with this manipulated variable. So in our case, we're going to drop the slotted weights from a certain height, correct? All right, so before you get started, think of what values you would like to use in this experiment. Come up with at least, how many do you think? Yeah, 5, right? Because you're going to do 1 and repeat 4. Why 5 values? Because remember that for physics SPM, it's about drawing a graph. And the minimum number of values you need to get a good graph is at least 5. That's why 5 values. So in this case, let's do 50 grams multiple. So 50, 100, 150, 200, 250. So for the first line, you just need to talk about the very first one. Now, before we go into how to write a procedure, please remember that you must write the procedure in passive form, not in active form. So just going to create a little bit of space here and show you, whoops, wrong file. What do you mean by active and passive? This is an example of an active form. Drop the slotted weights. You see, in active form, it's an instruction. You're telling someone what to do. Drop the slotted weights. Passive form is writing the line as if it's been done. The slotted weights are dropped. Now, for SPM, active form is not allowed for paper 3. So I'm just going to mark it in red to show you, okay, no, this is wrong. Okay. You have to write it in passive form. If you wrote your procedure in active form, no matter how wonderful and perfect experiments it's written, you're going to get 0 for the procedure. So make sure that you write it in passive form. Whether it's present tense or past tense, it doesn't matter. Which means that you can write the sorted weights are dropped, or if you write the sorted weights were dropped, it doesn't matter. It doesn't matter. Both tenses are accepted. Okay, but you cannot write it in active form. So writing in this way, you'll get no marks for procedure at all. Okay, so I'm going to just remove this from the document and go straight to the correct answer. So let's use 50 grams first in our as our first manipulated variable. So 50 grams slotted weight, okay, are dropped from, let's put a height that's logical, okay, from a height of say 10 cm onto the soft plasticine. Now for the second line, you need to measure the responding variable, which in this case is the depth of impact. So you just need to say the depth of impact in the soft plasticine is measured using the vernier calipers. Third line, repeat. Because you've already mentioned the first value, which is 50 grams, you just need to repeat 4 more times, which are the other values that we have determined just now, right? So you just say the experiment is repeated with 100 grams, 150 grams, 200 grams, and 250 grams of the slotted weights. And there you go. That's just 3 lines you need to write for the procedure. Next. Oops, let me put it this way here. Yeah, tabulation. Tabulation means you got to draw a table. Now, how many columns do you typically need? You only need to come up with 2 columns. 1 column for the manipulated variable and 1 column for the responding variable. So the first column is for our manipulated variable, which is the weight of the slotted weights, and the second one is the depth of impact. Let's say possibly in mm. Okay. Do you need to fill in the values in a table? You need to fill in the values, but for the manipulated only, because you already have the values that you have specified in the procedure. So you must fill that in. If you leave this blank, you will get no marks for the table. So we already have 50, 100, 150, 200, and 250. But for the depth of impact, which is our responding variable, you leave that blank. Because you haven't done the experiment, you have no idea what the value is. So leave it blank. Don't be too smart and, okay, I'm going to come up with 1 values. Don't. You're not writing a report. You haven't done the experiment. Okay, this is a framework. You are giving a suggestion on what kind of experiment could be conducted to study, what we observed in question 3. And last but not least is the, whoops, I wrote that wrong. Last but not least is our analysis. And remember that for physics SPM, analysis is always about drawing a graph. So you just need to suggest that a graph of responding variable on the y-axis against the weight on the x-axis is plotted, and you do need to sketch the axes. You do not need to sketch what the graph would look like, because I'm very sure you also don't know, is it a linear graph going up? Is it a curved graph? Does it curve which way? Whatever. You don't know? Yeah, because you haven't done the experiment. So don't be too smart and try to draw a graph out. You just need to sketch it. So I'm going to sketch that in the Jamboard here so that we can put that into our example report. So this is the weight and this is the depth of impact. Even if you don't put the units, it's okay actually, because the person who's going to draw the graph, not you, maybe somebody else, you give it to your coolie or something, yeah, they're going to have to draw that graph properly. But in this case, you're just suggesting what kind of graph should be drawn in this case. So I'm going to insert that here just for completion. And there you go. And that's it, 12 marks, just like that. Okay, so in case you were wondering, like, how are the marks allocated for section B? So what I've done is I've already say this is PDF, so that it's easier for me to circle and make markings and all that. Okay, as you can see in my guide, I've already written the marks allocation here, and I'll just go through this step by step with you guys so that you can see how this works. So as you can see, the inference is actually worth 1 mark, and it's already written here in the question. My computer crashed again, so that's why I have to reload this. Yeah, so the inference is worth 1 mark. And yeah, let's just make this a little bit darker. Yeah, this is worth one. Yeah, and this is worth 1 mark. The hypothesis is also worth 1 mark as per stated in the question, another mark. So 1 mark, which means this also gives you 1 mark. Okay. Aim is also 1 mark. So the aim is worth 1 mark. Variables. Variables are worth 2 marks, but this is how it works. Both the manipulated and responding correct are worth 1 mark, and constant variable is worth 1 more mark. By the way, in case you don't know what constant variable to write and you are afraid that the one you've gotten is wrong and you want to write more than one, that's fine. You can write a few here. The examiner will look for the correct one and give 1 mark, provided it doesn't clash or contradict any of the manipulated or responding variables. Appearance and materials are also worth 1 mark. That's why you don't need to split the list. You can combine them all into one line. The drawing, the dimension of apparatus, is also worth only 1 mark. That's why you don't have to make it perfect, but you must make sure that you have the labels. If you do not label, you will get 0 marks, no matter how beautiful your drawing is. Okay, just keep it simple. 2D is fine. Procedure is worth 3 marks. Like I mentioned earlier, the 3 mark allocation is for method to control the manipulated variable, method to measure the responding variable, and repeating. Tabulation, complete with the values in the manipulated variable, is worth 1 mark, and the analysis together with this is worth 1 mark. So if you count this out, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there you go, you get 12 marks. So that's how you solve the question for section B. I know that for this example, I've only done question 3, but I'm sure that you guys know now how to solve question 4 all on your own. If you have any questions or anything you'd like to check with me or any feedback, please feel free to drop in the comments below. Thank you all for watching. I hope you found this helpful and educational. Don't forget to click like and subscribe. I'll see you in the next video. Have a great week ahead and thank you for watching.